Welcome everyone to the 2020 APAC Groundbreakers virtual tour by APAC UC. This year, our event will be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs, from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions will be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page, and the speaker will be replying your questions on their earliest convenience. I would like to say thank you to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Cloud Native Application Development, build fast, cheap, scalable, and agile software on Oracle Cloud Infrastructure by Lucas de Lima. And please feel free to write questions at any time during the session by using the Q&A option on Zoom webinar, and Lucas will be answering all questions at the end of the session. If any issues during the presentation, please feel free to contact me at any time by using the chat option on the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Lucas de Lima. Lucas, I will stop sharing my screen and you can start sharing your screen, and I will put myself in mute.
Excellent. Thank you very much, Francisco. Good morning, good afternoon, good evening, wherever you are, whenever you are. I'm coming live to you from for me this morning. I'm in the Netherlands in an attic somewhere in Zoetermeer. And today I will be talking about cloud native applications. Cloud native application development, and I'm going to show you how to build fast, cheap, scalable, and agile software, specifically on Oracle Cloud Infrastructure. And I have a lot of ground to cover. And what I will do first, by the way, Francisco, I'm trying to share my video, but I'm for some reason not able to, so people can't see me. It's not like I want to hide.
No problem. I am enable your video right now. There we
go. Handsome, pretty me. There I am. Hi, everyone. As I was saying, cloud native application development. What I will do is introduce you to an application. I will describe the functionality, and I will briefly discuss how we would implement this functionality in a traditional way. And then I'll show you how we can implement the same functionality in a cloud native way. And you will see that it's much easier to get going with the cloud native way. We can focus only on the functionality we have to implement. We don't have to do anything to get the full stack up and running for us, and not just, we don't even have to get ourselves hardware or operating systems. It's all there for us. We can start using it immediately. We can sharing it. We can start sharing it with the rest of the world immediately. We can scale it if we want to. We can also scale it down if we want to. And we only start paying once we start using it in anger. And that is one of the great benefits of cloud native application development. Focus on the functionality you actually have to implement and get a host of other facilities for operations, for deployment, for scalability, get them out of the box. Not quite there yet. Let's first briefly introduce myself. My name is Lucas de Lima. I'm from the Netherlands. I work as a CTO for AMIS, which is part of Conclusion. And I go to customers, and then I'll be a cloud solution architect or a cloud architect or a solution architect or any type of architect you like. I'm a member of the Oracle Groundbreaker Ambassador Program, and I'm also an Oracle ACE Director and have been for quite a while. When we think about traditional applications, and of course that's just applications that are now stamping traditional because cloud native is a more modern type of application implementation. A traditional application consists of custom code, and this custom code uses third-party libraries and frameworks, and it exposes itself through a UI or an API or both, and then we call it a web application, and whether it's a monolith, a microservice, we call it module, it doesn't really matter in this case. In order to run it, we need quite a bit. We need a database to persist data, obviously, and that's something we have to install and manage in addition to the application. And in order to run the application, we also need a stack, and if this is a Java application, it would be the Java EE stack, which consists of an application server of some type, or at least a JVM and an operating system and hardware to run it on. And it's things we also need to put in place. And when we have such a stack to run our application on, we get a number of facilities. They are specific to the world of Java, but we can make use of them. But we also have to be very mindful of them. We have to know about them, and we have to do specific work to leverage them. So in a traditional application, there's a lot of work, and much of that work is not directly connected to the functional specifications that we're trying to implement. Now over to the cloud native application. In the cloud native application, we are able largely to focus on that specific functionality. And we implement that functionality in small bits and pieces. That's where we do our programming. EDAT low code programmers, we code only in these small bits and pieces that you see on this slide. And then we add things. We add facilities from our cloud environment, managed PaaS services that will help us with persisting data. And that run on this managed PaaS infrastructure that's on top of a managed infrastructure that we're not even aware of at all. And we can add additional facilities from this set of managed PaaS services, for example, a content delivery network and a web application firewall and an API gateway that will allow access for requests to go to our function. And we can add an event hub to connect in an asynchronous way one function to another. And we can add a container engine to run our web application if that's not a function itself, a serverless function. And we can add other facilities as well. We still focus only on the pink parts on this slide, and all the other things are things we get in a declarative, configurable way, but they don't require any coding, they don't require any management, or at least not much management, because they are managed services, not managed by us, that is. And we get facilities from this PaaS stack for monitoring, alerting, and notifying, for logging, for scaling, for auditing, and other things. And these are generic. Across anything we run on this cloud environment, they can all make use of these same facilities in the same manner, not tied specifically to any technology. Of course, it is tied to a vendor, our cloud vendor, and we are creating new vendor lock-in if we are not careful. Some of the characteristics and benefits, this PaaS layer is managed, and we can very quickly provision it and also very quickly get rid of it again. It's distributed, so we have disaster recovery and scalability across regions in the world. It's fully automated. We can all script, and we should script, the creation, the configuration, and the decommissioning of all these facilities. We pay per use, so our total cost of ownership depends on how much we actually make use of these facilities. If we have a lot of traffic, we pay more. If we have hardly any traffic, we pay little or even nothing at all. An important step here is that our cloud vendor takes runtime responsibility. Until 5 or 6 years ago, Oracle never used to do that. But now, if you're running an Oracle cloud, Oracle is part of your runtime situation. They're taking responsibility for the runtime behavior of your systems. That is a big step for Oracle and for us to put our trust in Oracle or in Amazon or in Azure. What's also quite important is that we get enterprise-grade platform components that are accessible to anyone. To me, in my attic in Zoetermeer, I can make use of facilities that in the past were only available to large corporations that could afford the licenses and the hardware to run the software on. And now I've got it on my fingertips, at my fingertips. So this allows for very, very rapid innovation. And since the cloud vendors are going through rapid innovation cycles themselves, we can very quickly benefit from the innovation that they produce. We don't have to wait for the next internal release cycle on our side to install the new versions of software. They come available right away from the cloud. We get security and availability at a level that would be very hard to set up ourselves. It's managed for us. And of course, we get the scalability to handle peak loads, to handle an ever-growing load of a very successful organization, and also to scale back and therefore scale back the costs when we don't have as much business anymore. So many benefits from cloud-native applications, and some of the characteristics that, of course, I've mentioned already. It's modern. That doesn't mean a thing. It's born in the cloud era. That really doesn't mean a thing either, but it may help you sell it to the upper management. From an architectural point of view, we focus specifically in the things that we build on, in cloud-native applications. We build on top of the stack. We focus on the interaction points, which are also the decoupling points. So between our custom components, we define APIs, and even more preferable, we define events and message formats for doing asynchronous interactions between components. When we, from our custom components, have to interact with the PaaS services, we can focus on the APIs defined by those PaaS services, the formats and the protocols. We don't need to know anything about the implementation of these services. There may be Kafka in this event thing, but maybe there isn't. And we don't really need to know, we don't need to care, because we only interact with the APIs that have been specified. So we don't focus as much on what technology is sitting underneath these services. Could be that Azure and Oracle are both offering a JSON NoSQL database service, and they both do. They both expose the MongoDB APIs, or at least the Oracle one will. And whether there's actually Mongo underneath or there isn't, we don't know, and we don't need to care. We can focus on our own custom code, and we can build it in small and simple units, things that we can understand, that we can handle, that we can own, that we can manage. We don't have to care about explicit infrastructure. Ideally, everything we do is serverless. At the very least, it's all software defined. We don't have physical hardware, but we also don't have to think about the hardware underneath our application stack. In the same vein, we can think in terms of statelessness and dynamic scalability, expand and contract. As I said, pay-per-use, and a strong focus on automation. No hands should ever touch the acceptance and production environment, and that means we get, in return, we can speed in rolling out our changes, we get repeatability, we don't get the human error when we try to quickly fix something in production, and we get the ability to dynamically adjust because we can configure these scripts with parameters that are either environment or condition specific. This, of course, is something you also know as infrastructure and platform as code. And for application, we would use automated CI/CD pipelines. So some of the capabilities we require from a cloud in order to be doing this kind of cloud-native development. What should this cloud that we use for this type of development, what should it offer to us? Well, it should support functions, serverless application code, small units that we can deploy that will be run by the cloud, and we don't need to know where it's running, what it's running on. It will just scale up, scale down, and we only pay per use. And we need something that we could call an API gateway in order to get requests routed to the proper function and to the proper other endpoints in our landscape. We need to have a facility for pub/sub, for queuing, for handling messages, so we can do asynchronous interaction. We need facilities for data persistence. There will be state. It will not be in the application or in the functions. It will be in a data persistence facility. We would like to have a cache. It may not be crucial, but in order to get the right performance and scalability, a cache probably is very important. We need security facilities, obviously. That's definitely something that we can benefit for which we can benefit from everything the cloud has to offer. We want to have these facilities to do automated operations and automated rollout. And of course, we need facilities to do monitoring. So these are all the things that our cloud should offer us. And apart from the cache, which is still not there in Oracle Cloud Infrastructure, all these required facilities are available on OCI. So what about OCI? Well, you probably are aware of Oracle and Oracle's two pillars. In the cloud, there's cloud applications. That's the SaaS department. And we're not going there. That's not where you create custom code. And there's the Oracle Cloud Infrastructure, sometimes called the Generation 2 Cloud, to set it apart from the Oracle Classic Cloud, which wasn't a huge success. And Oracle Cloud Infrastructure consists of infrastructure, hence the name, and also platform services. So the name may not have been chosen all that carefully after all. And Generation 2 Cloud, well, benefits from Generation 1. And there are all these lessons learned that are applied. And by the way, not just lessons learned from Oracle Cloud Generation 1, but also from the earlier activities at AWS and at Azure. And many people who used to work at Azure and AWS are now working at Oracle to help create this Generation 2 cloud. The main themes for OCI, and you probably have heard this before, very competitive pricing, as you can tell very easily by comparing with Azure and AWS. Security from the very core level, open technologies and APIs that allow you to access any aspect of the cloud, and enterprise-grade technology. As I mentioned before, even small companies can now easily make use of enterprise-grade technologies. There are trials, you probably know them, and there's this always free tier where you can get an autonomous database instance. Actually, you can get 2 instances or an autonomous data warehouse instance and run it for free forever. I'm not sure how long exactly forever will be, but for the foreseeable future at least. Oracle Cloud Infrastructure has regions all across the world. And there must be a data center pretty close to you, unless looking at the map, you're looking in Siberia or in parts of Africa. Other than that, there's an Oracle Cloud region pretty close to you, and it's expanding all the time. So some of the OCI services for cloud native application development that we will be discussing in this session, and some of them we won't be discussing, by the way, but they are there. We have a facility called Oracle Functions, based on Project FM. And we have an API gateway that handles requests from the outside world and routes them to functions or to other endpoints for that matter. And there's object storage for persistence. And there's also an NoSQL database, also for persistence. And there's streaming for queuing, for asynchronous interactions. And of course, there's also autonomous database. That's not on this slide, but it's also available for persistence. Streaming, of course, can also trigger functions to execute, hence the arrow back. Then in terms of UI, Oracle Cloud Infrastructure offers the digital assistant and visual builder. Then our own custom code, it can be in a function, but if you prefer, it can also be in a container that we might run on Oracle container Kubernetes engine, or you can run it in a VM on compute. Ideally, go for functions. If you cannot, use one of the other options. And then there are many other facilities that help us make our applications more secure, that help us to do auditing, that help us to manage the environment, and to roll out changes to the environment, either at infrastructure, platform, or our own application layer. And here are additional functionalities that we can leverage for operational management of whatever's running on our cloud. And all these services are available from OCI. Most of them are available for free, or at least when you start small, and they're all pay-per-use. So we're going to look at a specific application. Of course, its functionality isn't very meaningful. We're going to get all the tweets about Groundbreaker's tour. And I've also tried to do this with the hashtag for this event, but Francisco, you really picked a very difficult hashtag, but that is the one that I will be demoing. Basically, we want to create an application that gets all the tweets with a certain hashtag, and that then stores them in an NoSQL database, publishes them on a stream, and also sends email notifications about the tweets that have been captured. So this is the functionality that we'd like to implement. And I'm going to first discuss the traditional implementation very briefly, and then discuss the cloud native implementation at some detail. So the traditional implementation probably would look something like this. And it could be in Java, it could be in Node, it could be in Python, it could be in any programming language. We would expose an API. The API would invoke programmatic components. They would make use of third-party libraries for interacting with the Twitter API, but also to perform logging, for example. There would be a library and a custom component for sending the emails. We would have another custom component, object, class, module, whatever, to write to the NoSQL database and also to publish to streaming. And of course, in order to make it run, we would have to build this stack, this Java E stack or Node runtime environment, including an operating system, perhaps publish it as a container and run it somewhere on an execution environment that we then also would have to manage. And this application probably would go in there as one big building block that could easily end up being a hard to maintain monolith. We would have to set up a database and we would have this stack to run it. Would we at that point have logging analytics? Would we have monitoring facilities? Would we have auditing facilities? Well, we probably would have to create, install, and connect those ourselves. So this is the traditional way of going about creating an application. There's not necessarily anything wrong with it. It's something we have been doing for at least 2 decades, but there is an easier way now, and that's the cloud native way. So what does the cloud native way look like for this same application? And my design, and there are more ways to skin this cat, but my design has 2 fairly small sections of custom code, the 2 functions that you see on this slide. The first function will interact with Twitter. It will read the Twitter credentials from the vault, which is one of the OCI services. It will then write a file with the contents of all the tweets that it has captured to object storage. And this act will trigger an event that through the notification service will result both in an email being sent and in a second function being triggered. The second function reads the tweet contents from the JSON document of object storage and then writes the contents to the NoSQL database and also publishes the content to a stream. In order to get all this to run, I need to configure but a few things. So here's the story again. By the way, all these slides, of course, are available. One of the things I would like to point out in any application, but certainly in a cloud native application, by using this application as an example, we require, as architects, as developers, we require decoupling. We want to create boundaries between various components so that each component can be changed on its own, can be taken down on its own, can be evolved on its own, can be scaled on its own. A problem with one component should not affect the other components, or at least not any more than it has to. That's one reason why we don't like synchronous interactions between components, because those are hard dependencies. And in this application design, facilitated by the cloud environment, we have a lot of those decoupling points. So at each point, we end the action from one end. We may trigger an action from the other end, but the 2 ends are not directly connected, do not have hard dependencies, they are decoupled. This not only applies to cloud native applications, of course, this applies to any application. So in order to prepare for this application, what do we need to do? Well, we need to get ourselves an OCI tenancy, for example, in a trial account. We get many things out of the box, but we have to set up a number of things in order to get us to work. So we have to configure with a wizard, for example, a virtual cloud network. This may sound a bit daunting, but it's really very easy. I could do it, I know nothing about networking. We have to create a specific compartment, which is almost like a folder, a logical area. We may need Well, we do need a dynamic group for the API gateway and for functions. That's a little bit involved, but still not too hard. We have to create a vault for the Twitter credentials. We have to set up a skeleton API gateway into which we will create our API deployments. We have to create a bucket on object storage. We have to create a NoSQL database table. And I think this is it. We need to set up configuration of the logging service in order to capture the logging produced by our functions. By the way, preparing all of this is something that ideally we would do using a Terraform plan that is executed by the resource manager in order to create these resources on our OCI environment. So the implementation then of the application itself, we can focus on the functionality. And in this case, we'll start with the function tweet summarizer. That's a function that will be triggered somehow by a request. And then it will get the Twitter credentials from the vault. It will invoke the Twitter API, create a JSON document, and write that to object storage. That's all it has to do, and all the other facilities are there to benefit from. So very briefly about functions on OCI, they're based on Project FN. You can write your functions in any major programming language or even using a custom Docker container, and then hand it to OCI for execution. So the request handling basically consists of your own implementation combined with the function development kit. We'll get any HTTP request and we'll make sure that all the information from the HTTP request is handed over to your function implementation. And in your function, you know what was the contents of the HTTP request. Now, after creating the function, this is what it looks like on OCI. And I probably can show you this in a moment. And what you can see on this slide is that the function has reference to an image. And image here means Docker container image, because the implementation of the function by the FN client tool is built as a Docker container image stored in the Oracle Container Image Registry in the cloud. And that's what the function is actually based on. So when the function is triggered, based on this image, a container instance is started and it will process the request. The code for this function is on GitHub, and the link I gave you at the first slide and will give you again at the last slide, it points at this GitHub repository and you can inspect the code. It's just normal Node code, JavaScript code, nothing specific. It does a number of interesting things. It invokes a number of OCI APIs to trigger PaaS services, and it interacts with the Twitter APIs. It also makes use of a number of environment variables, and these environment variables are set as configuration settings on the function. So in the OCI console, typically set through scripts as in infrastructure as code, also in an automated fashion, and we can define the values that are injected into our functions at runtime as configuration parameters. In this case, for example, the name of the bucket on object storage into which the tweet reports should be written, and also the credentials for accessing the Twitter API. Or actually, the identifier of the secret in the Oracle Vault that contains the Twitter credentials. So it's indirection. We don't actually see those credentials here. We only see the identifier of the secret that contains the credentials. So here's the application design again. And in order to expose the function, we need to do something. First, very briefly, a comparison between the functions and containers and virtual machines, because these are all options to run your own application code. There are a lot of things to look at. The most important distinction is at the top. With serverless, we don't have to do any infrastructure DevOps. We don't have to think about it. We don't have to manage it. With containers, we have some, and with VMs, we have a lot. With functions, we have a stepless pay-per-use. Use nothing, pay nothing, use a little bit, pay a little bit. With containers and VMs, it's not as stepless. Please take a closer look but my advice would be if you can get away with functions, especially initially, it's much easier. So I would go for the functions. Here's the object storage service. I will show you this in a moment. And then, as I was saying, how can we trigger the execution of a function on OCI? Well, there are actually quite a few ways. We can do it from FN. We can do it using authenticated signed HTTP request, but the easiest way is to set up an API gateway and allow any HTTP request that's authenticated in the way we want it to be able to trigger a function execution. Other triggering mechanisms are events, are notifications that, for example, are triggered by monitoring alarms, and is the new service connector that you can use to have functions process logging. We can also execute functions from a Terraform plan. You could indicate or mark all of these interactions as either belonging to the ops automation domain or the application functional domain. Of course, this doesn't really mean a thing to OCI, but just that, to keep in your head that functions can play an important part in our business functionality, but also in our ops responsibilities. So in order to expose the function, I want to set up an API gateway. And this API gateway, as I said before, it handles HTTP calls, and it can perform authorization, authentication, it can do routing, it can do mappings. As of last month, it can also do transformation of the headers, and it also provides observation of what's going on. So it monitors, it audits, and it logs. As a backend for the API gateway or endpoint, you can either have a mob implementation that provides a stock, a hard-coded response, any third-party HTTP endpoint outside of OCI or inside of OCI, and also, and this is the interesting one, or in this case, the interesting one, it can trigger a function execution. So here are some of the things that API gateways can do for us. The configuration basically consists of defining what's called a route. Inside an API gateway API deployment, we can define multiple routes. Each route corresponds to a certain URL path, to a certain HTTP method, and then to a certain endpoint. And in this case, the HTTP method is GET, the path is Groundbreaker's summarize tweets, and it will trigger the function tweet summarizer. So if from my browser, and let's now go there, if from my browser I invoke the API gateway with this path and this hashtag, so this is the very long hashtag that Francesco came up with, by sending this HTTP request, I'm triggering the function. And since the function has not been triggered for at least 15 minutes, it's now a cold start. So the function is not running. The Docker container image needs to be started. And only when it's started will it be able to handle the request. So this first request takes up to 25 seconds. As soon as it's done, I can send another one. So now it's done. I can send another one. Show you the difference. Let's add another parameter. And now it's done in less than a second. This request should have produced, let's first take a look at the function. So here we are on OCI console, and under developer services, there are the functions. You also saw the API gateway. And this, of course, is not what should happen. Not sure why it's happening. So there we go. Back in OCI console. Let's go to developer services, functions. And in the Lab 1 application, an application is a logical clustering of functions. There are two functions, and the tweet summarizer was just invoked. So if I look at the metrics for the last hour, you can see that there have been a number of invocations, and the last one was, well, just now, actually 2 invocations. And of course, if I invoke again, there will be another invocation. If I go to object storage, and I look at object storage and go down here, I will find a bucket called Twitter reports. And in this bucket, there will be a file that was just created. Actually, there will be 2, 7:34:49 UTC. That's 2 minutes ago. And this is, well, also almost 2 minutes ago. And these are files in my own way. So if I look at the object details, I can see the actual contents. of the document, and I can see the tweets that have been there, for example, by Sven Bernhard, the tweets that have been there in the last few hours. So this is the first part of the cloud native application. I only had to implement a function, a piece of Node.js code, and all the rest was configured around it, including the API gateway, including the object storage service, including the security to store the secret with the credentials for Twitter. So from functions, I can make use of various PaaS services that are available in OCI. From a function, of course, I can also invoke API gateway, and from API gateway, invoke another function. So I can have synchronous interactions between functions that I don't necessarily like, but they can be there. I can publish a notification, and the notification can send an email. Oh, by the way, I should have shown you that I've also received an email just now because of the tweet document that was created on object storage. So this email was triggered by an event, a notification on OCI that was scheduled to send an email to me when this event occurs. And again, that's completely declarative. I didn't implement any code for sending this email. A notification can also trigger a function. So here is a different way for functions to invoke functions in an asynchronous way. And from functions, I can invoke other OCI services, such as, well, the ones shown on the slide. And functions automatically, they don't have to invoke them, benefit from logging, monitoring, and auditing. I really have to do nothing. Well, I have to configure that I want to have logging assembled, collected in a certain group. That's the only thing I need to do. So how to trigger the processing of the document, for example, to an email, but also to the stream. Well, I want an email to be sent when the document is created, and I just showed you that this email already is sent. So how was that implemented? Well, it has been implemented using cloud events and notifications. Cloud events, I should explain, cloud events are on the left, are things that occur inside of OCI. Anything that happens in OCI can result in a cloud event that's published. And if you set up an event service to send that event to the notification service, or to be handled by a function, or to be pushed to a stream, then it's processed further on. So if anything happens to an OCI resource, a cloud event can be published if that resource is enabled to emit these events. And based on event rules, a notification can be published, or a function can be triggered, or a message can be pushed to a stream. The notification is put on a notification topic. This is like a pub/sub queue, and subscriptions can be made on this topic. Subscriptions can be made by a number of services or channels. Functions is one of them. Streaming, again, is also one of them. Email, in this case, it was email, is also one of them. There's the option to define a webhook, any HTTPS endpoint, to send a message to a Slack channel or to PagerDuty. So a cloud event is published because something happens to an OCI resource, and then based on the event rules, the notification subscription, it ends up with the email service that sends out an email. Other ways to publish a notification to a notification topic are from functions or from a monitoring alarm, and they can have a similar response. So here, and I don't have time to go into detail, here is an example of configuring the event rule for creating a document on object storage in this specific bucket. And here is the associated action, publish a notification to a notification topic. And here is the instruction to send an email to me when this happens. And this is something we're going to skip. So when the tweet summarizer, the function that we first discussed, is invoked, what will happen is that an email is sent. That's the end result. There we go. Event is published, notification is published, email is sent. Now the next step we have to take is to write the tweets to the NoSQL database. And for this, we will create a second function. The second function will be triggered by a notification. It will go to the object storage service to get the JSON document, and then it will process the document and create individual tweet records in the NoSQL database. Very briefly about this NoSQL database, it was launched in February. It's based on the Oracle NoSQL database, which itself is based on the Berkeley DB storage engine. It's really not just NoSQL. It's also quite relational. It supports SQL, it supports ACID transactions, it supports a multi-region architecture, it has built-in data redundancy, and there's this very neat feature, time to live, and auto expire on record, so you can specify for how long records should be retained. So it's actually quite nice. And then as of August, we also have the autonomous JSON database service that you may have heard about. And that is at least somewhat similar in functionality. For this demo, I've used the NoSQL database, but I could probably have used the autonomous JSON as well. So in OCI, I will define a NoSQL database table, a tweets table. And if you know SQL, then you know how to create such a table definition. And here you see the result of processing those tweets from the JSON document on object storage and creating records in the NoSQL table. And of course, I can access this data through a REST API, through the SDKs for the NoSQL database, and also in the console. And here I'm executing a pretty simple select statement, and you see the result. By the way, these are tweets from a presentation I did in August. So I also want to publish to the stream. What do I need in order to do this? Well, I first have to create a stream, and the OCI streaming service is very similar to Kafka. It's a publish subscribe mechanism. You publish events. These events are persisted by the streaming service, and subscribers can come in and pull those events. There's no automatic push. So like I said, it's Kafka-like. Events are published and consumed through REST API calls, and there's also a Java SDK. There's no automatic push to a consumer, so you have to come in as a consuming application to pull for the events on the stream. Basically, that's how all these mechanisms work. So in this case, each tweet that's written to a database record is also published as an event to the stream. And if I fire up my function again, it takes about 2 seconds. At this point, the document is created, a new email is sent, records will be written to the NoSQL database, and the stream will be published. In about 30 seconds, I can show you the messages on the stream. It will look something like this. This is a screenshot I took this morning of the actual records on the stream based on the tweets about the event that I'm currently presenting as part in. So the monitoring service has something called health checks, and health checks allow you to look at your services through the eyes of an external client that could be anywhere in the world. So with the monitoring health check, you can instruct the OCI to set up periodic HTTP calls or TCP IP pings to your endpoints inside OCI, and these requests should be made from outside OCI to make sure that your service is actually available. It's quite nice. You can use it for health checks, for live function, also for smoke tests. And you can also, so that that would look, in the case of our function, it would look something like this. The health check invokes the API gateway, which triggers the function, which should have some sort of result. And this should result in a 200, 201 HTTP status. Now you can use this as a trick for scheduling functions. One of the things OCI does not have is a mechanism for scheduling any kind of activity, including functions. So if you want to set up a scheduled function execution, what you could do is use a health check and schedule that health check to run every 30 seconds, 60 seconds, 5, 10, or 15 minutes to make this call to the API gateway that in turn triggers the function. Here's some more details, don't need to go into that. Using a monitoring alarm is another way of scheduling through a notification, scheduling a periodic execution of a function. Of course, these are workarounds, and we really require OCI to provide a job scheduling mechanism. Hopefully, I'm still in time to capture my streamed records. So in analytics, there's streaming. Under streaming, there is the lab stream, and in lab stream, I can ask for. I think I'm just too late for the last minute of messages, and I'm just too late. I talk too much. If you are going to work with OCI, you might want to take a look at Draw.io, where you can very easily create solution diagrams. And there's actually a set of icons that represent all the OCI services that you can use for Draw.io. So, summarizing, here is my cloud native application, and the slide may look a bit complex, but the only things I had to do myself is implement the two functions and do very little preparation in terms of configuration on some of the other services. The rest came out of the box, didn't require any action on my part. And I pay for this per use. So the TCO really depends on the benefit I'm getting from anything I've implemented. I want to prove that I have my, there they are. So these are the messages captured from the stream. Sorry, I just needed to prove that the demo is working. So reiterating, pay per use, very low TCO. In fact, you might think you have to pay a big pile of money in order to get all of this to work for you, but you don't. You have a very small pile of money, and actually, there are many reasons why you may probably not pay anything at all. In my case, I don't pay anything at all because all of these services have are either part of the always free tier, have a first X free allowance, and even if I would go over the threshold of this free allowance, the unit price is still extremely low. The other benefits I'm getting, well, these are platform services, they are managed for me. I don't need to know anything about service, about infrastructure, about where things are running, how to scale them. They are very quick to provision and to decommission, but of course, since I'm not paying anything, since it's serverless, I don't really have to decommission. It's distributed out of the box. It supports automation out of the box. The vendor, Oracle, takes runtime responsibility for running all the underlying servers and networks. I don't do anything for that. It's enterprise-grade platform for all. It's for me in this case. Security and availability out of the box. Scalability, I don't really need it in my case, but it's there out of the box. And all these operations facilities that are really very powerful and very important to monitor, to log, to audit. And I didn't even show you the monitoring, the auditing facilities, the cloud events, and the automated failover. And I'm getting all of that out of the box from my attic in Zoetermeer. And this enables me to do very rapid innovation, to benefit from everything Oracle is doing, and also to very quickly try out new services for myself because of all the advantages mentioned overhead. With that, and a little late, I would like to thank you for your attention. I hope this was useful. Here is the link to both slides and the code for the functions. And the functions, as I said, are really all that my application, my cloud native application consists of. And at this point, I should probably take a look at the Q&A section, if I can find it, to see if there are any questions, and there appear not to be any. Well, if that's the case, this is the end of the session. Thank you very much. Have a great rest of the day. Of course, if you have any opinions you would like to share, I would be very interested in those as well. Thank you very much. some real-world examples that this has been used for. Well, one example I can give is the IoT platform that I'm building for a customer in the Netherlands. Here we are reading telemetry from over 100,000 devices that are installed in people's homes. Telemetry is coming in from each device once every hour, and we need it to be processed in a number of steps. So first of all, we need to receive it and validate it. Then we have to store it. We have to publish events based on the telemetry we receive. And we also have to make the information about this telemetry available in a dashboard. And for each of the 4 or 5 different steps in processing the telemetry, we have created functions. And the functions are connected to each other in an asynchronous manner through events, as I was discussing in this talk. And the benefits are that we have to focus only on these 5 functions that we are implementing. Each of these functions has a very specific role, is fairly easy to understand and to work on. All of these functions are deployed independently, they are scaled independently. And since they are interacting in an asynchronous decoupled manner, we can take one function down, change it, reinstate it without losing any work, because all the work is retained in these decoupling points. In terms of very quickly getting started on this platform, and also in terms of not paying very much initially, because we started out not with 100,000 devices, but with only 13 devices. For the first few months, we didn't pay anything in terms of cloud costs, or just a very tiny amount, because our usage was very small. But the same environment is now capable of easily scaling up to tens of thousands and hundreds of thousands of devices. And of course, in this case too, we got monitoring out of the box. So now we are live, we are in a production situation. In fact, last night we had a production issue. But we get all the information from the cloud environment without us having to create many complex monitoring facilities. I could talk about this for a length of time, but hopefully I've given you at least some idea of the benefits that we got from going about this in a cloud native way. If there aren't any more questions, remarks, or even people in the session, I think we probably should call it a day. Are you hosting another session as well, Francesco? Maybe now's an opportunity to sing some songs for you. Or continue the discussion in Dutch. So Francesco can add another language to the 4 languages
Yes.
we already...
No worries at all. All good.
So you are there.
No, it's all good, all good, all good. Did you check the chat? The chat only says thank you to everyone.
Yeah,
Everybody
and there was one question in the Q&A, and I think I just answered it.
Fantastic. No, in that case, thank you so much, Lucas. And again, this session will be available for playback for 2 weeks. In a couple hours, will be available to the people to revisit. And any questions you have, please feel free to post in the replay page of this session. And Lucas will be notified, and he will be answering our questions on the replay page as per his earliest convenience. Or you can also contact him by his email, his Twitter handler, or LinkedIn that he have on the screen.
Yep, that would be great.
So much. Thank you, Lucas, and have a wonderful day, and please be safe over there.
Thank you very much. And once again, my congratulations on your great event. I really enjoyed watching many sessions already, and I will watch some more in the next few weeks.
Fantastic. Thank you, my friend. Take care. All the best.
Bye-bye.